Hello everyone, my name is Farhad Ghani. Today I am presenting my research on predicting student performance in an online learning using big data, machine learning and neural networks. So this research leverages frameworks Hadoop and Spark for big data storage and processing, also applying supervised and unsupervised learning technique to examine a student survey dataset which is gathered by the Monster Technological University during the time of pandemic 2021. So the project objective are identify main reason that impact student success in an online education. Big data technologies like Hadoop and Spark used to examine how well machine learning and deep learning model predicting student achievement in an online learning. Furthermore, several supervised and supervised learning approaches used to examine important element impacting student performance in an emergency remote teaching. Moreover, comparison of neural network, which is long short-term memory, recurrent neural network, and feed-forward neural network with machine learning model, random forest, and decision tree to evaluate accuracy of the models. So we will be appropriate model can be a solve research problem, and also key finding will allow us to recommend the best predictive model for similar data set. There are four problems to set to solved. One problem with the binary classification. Second is the multi-classification and the sentiment analysis and clustering, K prototype clustering, which is good for mixed data. And two is the supervised learning task, and two is the unsupervised learning task. For the data processing, I have done the data cleaning, which is handled missing values and renamed the unclear column names. PySpark, I have used the transformation of scaling data where to categorical features scalability and efficiency. Also, data was split into 80% of training and 20% of testing, and to ensure that the data is appropriate format. The 2D data shaped into a 3D because it was required for the long short-term memory. And also data storage, I have used the Hadoop. For the feature engineering, I am using string indexer where numerical data where categorical data converted into numerical and such as 0 1 2, and then one hot encoder followed by the string indexer and converted in category is represented by a 1 and categorized by a 0, because machine learning algorithm work well with the numerical data. And also then vector assembler is required to create a single vector column that can serve as a model input. All of the one hot encoder column are combined using a vector assembler. Also one vector is created by a concatenated and all of the encoded features, and this vector is subsequently fed into a machine learning model. So first problem key findings are that the random forest outperformed with its high metrics and perceptions recall. Also F1 score also close to 100%, and the result proof that the random forest performing accurately also balanced well with the false positive and false negative. Furthermore, comparing recurrent neural network, recall, and random forest, slightly lower difference noted. However, perception for both model are 100%, which suggests that predict positive perfectly. When computing feed-forward neural network perception and recall with random forest, slightly lower difference noted, which suggests that feed-forward neural network have some false positive and false negative. These are the key finding for the second problem, and that was the multi-class classification. The decision tree outperformed with its high metrics, and in all four metrics highest achievement proof that the decision tree balance well with false positive and false negative. Furthermore, long short-term memory had lower accuracy to be expected due to the structured nature of the survey data, which possibly will not advantage for from sequence based learning. This is a key findings for the sentiment analysis, which applied on question 13, which was the preference method of study, such as online learning or on campus study. And it is observed that the result score suggested that 86.44% students neutral and 13.56% were positive to study online, and there is no negative preference were recorded. Um, so these are the key finding of K prototype clustering, and where the K is selected 7 by the calculation of WCSS, and also the 6633, which is indicate that the moderate to good quality of clustering. Furthermore, 0.86 6896, which is also emphasized that clustering are fairly clearly separated, grouped, and however, some of them are overlapping that could be reduced by a clustering, and that could be improved by reducing a clustering. So, in conclusion, research question 1 and 2 is achieved by the understanding of random forest and decision tree are more effective outperformed due to structured categorical data, and the big data tech frameworks Hadoop and Spark improved accuracy of student success predictions. Also, the training time, training neural network are simpler with the simpler architecture for with the feed forward neural network than the LSTM or recurrent neural network. Furthermore, question 5 is obstacles. The obstacles face hardware requirement, power consumption, and training time, which resolved with the PyTorch and learning models, learning scheduler, and stopping technique. Furthermore, the combination of big data neural network enhance the academic achievement by using a virtual environment in implement and using these models. Here is some future improvements which we can do in this project, such as the fresh data can be collected, which could be a different generalization, and also furthermore utilization of hybrid model technique can be improve the accuracy. Also the additional like advanced learning models such as transformation model and in reinforcement learning can be used, and also we can experiment with the BART-based NLP model to improve accuracy of sentiment classification. And and finally, thank you so much for listening to my presentation. And I'm very thankful to my lecturers and supervisors who shared their knowledge and experience with me to complete this project. Thank you so much again.